Screen is visible.
Yes, sir.
Okay. So today we will try to complete this fat. Okay. So we will discuss about like introduction of fat, types of fat, and metabolism of fat, digestion of fat. So indirectly we are covering two or three units together. Then we will not need to again complete unit third again, unit fourth again. We are directly covering all the units together, and we are trying to cover all the similar topic once. So today we are discussing about fat. Fat is an essential part of our body, and just like as we discussed, like carbohydrate provides energy to our body and protein make structural framework of our body. Protein is like main root nutrient that is present in our structure, but fat mostly and mostly fat do both the function. Like fat also provide us energy, and fat is also responsible for structural framework. That is very much energy dense. Usha ma'am, I made you host, so please allow all the student.
Yes, sir.
Okay. Okay, so these both these function are carried out by fat. Like fat also provide us energy, and fat also consist our structural framework. So our sixth of body weight, so it is around 17% of our body is made up of fat. Fat is present in various region in our body, like in cell membrane, fat is present. Beneath the skin, fat is present. The cells and tissues of our body have fat as an integral part. The vital organs are protected by fats and other lipids. So as a protection, we have two layer of fat. You can write this down. Two layer of fat we have. One is subcutaneous fat. So this layer of fat present just inside our skin, and this fat layer act as a we can say insulator that do not allow energy to flow outside our body. So this layer of fat is responsible for maintaining our body temperature. If this layer of fat will not be present in our body, then what happen, our whole energy will goes to environment through our body, and then we can't survive. So this layer of fat, subcutaneous fat, act as an insulator, and it saves our energy inside our body. It saves our heat inside our body. And those animals which are present in very cold condition, in those animals this subcutaneous fat layer is very much thick. Like you have heard of Arctic wolf, you have heard of whale. All these animal, those lives in water, or those lives in very cold climate, have very thick layer of this subcutaneous fat. Other fat is visceral fat. Visceral fat present around our important organ. So imagine you are packing some gift, or you are packing some uh, important or a valuable thing. Then when you are doing packing, you put some cushion, or you put some material inside that prevent that material from breaking. Similarly, in our body, most of the packing done in the same way. Like first there is hard covering of bones. Just take example of brain. First there is hard covering of skull, then there will be soft covering or cushion of fat. Then inside there will be that vital organ will be present. Similar things happens with our kidney. First there is hard covering of our ribs, kidney are being protected by our ribs. Under the ribs, kidney are present. After that, there is a cushion of adipose tissue. Then kidneys are inside that cushion. So this packing is present in our whole body. So this fat also act as a cushion to our main vital organs, and this fat is known as visceral fat. The nerves are also protected by fat. In our neuron, there is also some layer of fat present. The layer of fat beneath the skin act as an insulation against cold. This we already discussed. The fat around the joint act as a lubricant and allow us to move these smoothly. The fat that is present around the joint, and we also known as like synovial fluid. That synovial fluid, that synovial fluid is not actual fat, but it is a derivative of fat. So that allow a lubrication, like it acts as a lubricating agent, so that there will be no proper contraction of bones, and there will be frequent movement of bones. Okay, now let's talk about structure of fat. So basic uh, structure of fat, if we talk about basic structure of fat, the basic unit of fat is fatty acid. Just like basic unit of carbohydrate is monoglyceride, just like basic unit of protein is amino acid, similarly the basic unit of fat is fatty acid. Fatty acid are main building block of fat. So let's discuss about the structure of fatty acid. Uh, I hope all of you are aware of structure of protein.
Yes, sir.
Okay. Please keep that structure in mind. Now we will discuss about structure of fat. So structure of fatty acid, and one more thing, please don't confuse between fatty acid and fat. These two are different terms. Fatty acid is structural unit of fat, means fat is made up of fatty acid, but unlike protein, there is a difference. Like monosaccharide forms carbohydrate, but there is a difference in both two process. The difference is that in carbohydrate only monosaccharide are present. Similarly, when amino acid form protein, in a protein molecule only amino acid are present, but this is not apply in fat molecule. In a fat molecule, fat is made up of fatty acid as well as many other substances, many others molecule. These molecules, these substances are different according to different types of fat. Are you understanding what I want to convey?
So probably it needs a bit more explanation.
Okay, like I want to explain, like in a protein, there is only amino acid. Only amino acid forms a protein, but fatty acid alone can't form fat. There is something, some other molecule will present to join these fatty acid. So fat is made up of fatty acid as well as some other molecule. These molecules are different according to type of fat. We will discuss this later, then you will be more clear on this. So this is structure of fatty acid, not structure of fat. So this is basic structure of fatty acid. In this, there is a methyl group. As I already told you, methyl group is long chain of carbon. Different carbon atoms will be joined to each other, cs3, cs2, cs2. It may be 3 carbon chain, it may be 6 carbon chain, it may be 100 carbon chain. So in this R is methyl group, means carbon chain with hydrogen, and this R is joined with a carboxylic acid group, C. We can write this as carboxylic acid group. So carboxylic acid group, just like in protein, there was amine group. Amine group means NH3. Similarly, in fat, there is carboxylic acid group. Carboxylic acid group is C double bond O single bond OH. This is carboxylic acid group chemical formula, and it is connected with a methyl group R. So this is the structure of one fatty acid. Again, I am repeating, this methyl group R will be connected to one carboxylic acid group, and this is carboxylic acid group C double bond O single bond OH. No need to go in much depth of this chemical formula. Just try to remember this, like R is connected with carboxylic acid, and carboxylic acid is having formula C double bond O single bond OH. There is no need to go in depth like why carboxylic acid is formula, why there is difference in amine. You just need to remember these terms. Okay, this is detailed picture, like these are carbon chain. And what they have done, please don't confuse in this picture, what they have done, in place of writing CH3, they directly show the detailed picture like C, H, H, H. In place of writing CH2, they wrote C, H, H. So what we have written here, this term CH3, CH2, CH2, they just expand that, like CH3 means 3 hydrogen are attached to carbon. So 1, 2, 3, then CH2, then CH2. And at the end, there will be one carboxylic acid group. Carboxylic acid group means C double bond O single bond OH. Any doubt in this structure of fatty acid?
No, sir.
Okay. Okay, this thing also remember, about 20 fatty acid are found in food and body tissue. How many amino acid were there?
22. 22.
Yeah, 22 amino acid. And out of 22, how many amino acid are biologically important?
20. 20.
Amino acid are biologically important. Very good. Okay, next. There is classification of fatty acid, short chain or long chain fatty acid. So short chain or long chain fatty acid, this classification is only on the basis of number of carbon atom present. Like short chain fatty acid contain only 4 to 6 carbon atom. Like this picture. If there is 4 to 6 carbon atom like C, 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 and then this carboxylic acid group, it will be short chain fatty acid. If there will be long number of carbon atom, like if there will be 8 to 12 carbon atom, then we call it as medium chain fatty acid. Similarly, if there will be more than 40, if there will be 14 to 18 carbon atom, then the chain will be long chain, and more than 20, then it would be extra long chain fatty acid. So this is very much simple, like number of carbon atom is deciding whether the chain is short chain and whether the chain is long chain. If there will be 4 to 6 carbon atom, it would be short chain fatty acid. If in a fatty acid 14 to 18 carbon atom are present, then we call it as long chain fatty acid. If there will be more than 20 carbon atom, then we will call it as extra long chain fatty acid. This is not very much important, but what we are going to discuss next, saturated or unsaturated fatty acid, this is very, very important. If a question asked in exam from this fat, then there is 70 to 80% chances the question will be from this saturated or unsaturated fatty acid. It is also very much simple. First, we need to discuss what is saturation and what is unsaturation. So saturation and unsaturation is based on bond. Okay, just a minute. Okay, can any one of you describe this term saturation? What is saturation? Just normally.
A peak point in which we cannot add anything more that has reached its peak.
Yeah, a peak point in which there is no chances that something can be added. That is known as saturation point, or uh, the condition is then saturated. So saturation is something you can't increase something or you can't add something. Like if you're trying to improve yourself, first you will improve. Then there is a point, there will be a point where no chances of improvement were there. You can't improve then. So that point is known as saturation point. So in fatty acid, what is the valency of carbon? Okay, just don't confuse in this. Valency is very much easy. Valency means a total number of attachment. Well, carbon has four valency. Valency means total number of attachment, means a carbon atom can be attached to four number of atom, or a carbon atom can have four attachment. So let's discuss a molecule CH3, CH2, uh, CH double bond, CH3. So in this molecule, there is a double bond present, means carbon can attach to four. Okay, this is just explanation of saturated and unsaturated fatty acid. If you are not understanding this, uh, after this I will just told direct method, like what is saturated, what is unsaturated. But I am explaining saturation. If you understand this, it's good. If you are unable to understand this, then it is also good. So in this, carbon is attached to other carbon atom with a double bond. So we can do one thing. We can remove this sing we can replace this double bond with a single bond, and we can add one more hydrogen. So that structure, this structure allows some improvement. This structure allows some addition of hydrogen. So this structure is allowing some addition. So we called it as unsaturated. Means there is some chances of addition of hydrogen. Okay, one more example I will take. Let's discuss these two molecules. One is C H H H CH3 C H double bond C H H. In this molecule also, we can just replace this double bond and we can add hydrogen. So this molecule in which a double bond is present, there is chances of addition of hydrogen. So we called it as unsaturated molecule. But this molecule, if we replace this double bond with hydrogen, so we can't add more hydrogen in this because all the double bonds are filled with hydrogen. So in this molecule, no other hydrogen can be added. So we call this as unsaturated molecule. Okay, so hope you understand. Is
Yes,
it
sir.
clear?
Sir, only when there is a double bond, there is a possibility of change in the structure, then it becomes a unsaturated bond.
Yeah, then it is unsaturated. Yeah, and
If there is
when
no double bond, then it's a saturated
yeah,
fatty acid.
then it was saturated. Yes. So if someone is not understanding this saturation or something, then you can directly learn this, like saturated fatty acid has a single bond between its carbon atom, don't have any double bond. These saturated fatty acid have whole single bond. Unsaturated fatty acid have one or more double bond in their molecule. They have one or more double bond in their molecule, and on the basis of double bond, these are divided into two type: monosaturated, unsaturated, or polyunsaturated. So monounsaturated fatty acid are those fatty acid which have only one double bond in their molecule. Mono means one. So there is only one unsaturation, means there will be only one double bond. Polyunsaturated. Poly means many. So polyunsaturated fatty acid means there will be many double bond present in the molecule. So again, I am repeating, if a fatty acid is saturated, it means no double bond. If that is MUFA, we call this as MUFA, monounsaturated fatty acid, then how many double bond will be there?
One.
One double bond. And if this is okay, sorry. If this is polyunsaturated fatty acid, then how many double bond will be there?
Many.
Yes, there will be many double bond. Is anyone having doubt in this?
No, sir.
Okay. Now let's discuss its clinical importance. What is clinical importance of saturated and unsaturated fatty acid? Uh, First, discuss the example. Uh, all the animal fat, whether it is dairy, whether it is meat, all the uh, animal fat contain saturated fatty acid. Keep this on your mind, like all the animal fat, whether it comes from dairy, whether it comes from meat, it will always have saturated fatty acid. And all the plant sources except coconut oil and except palm oil, all the plant sources contain unsaturated fatty acid. So these two are very much important, coconut oil and palm oil. Oil and palm oil contains saturated fatty acid, and unsaturated fatty acid are all plant except coconut oil and palm oil. Is it clear?
Sir.
Okay, now no need to remember example of poly unsaturated and mono unsaturated. Just you need to know the concept, what is poly unsaturated, what is mono unsaturated. Now in a short discussion, we will try to understand like what is the clinical importance of saturated and what is clinical importance of unsaturated fatty acid. Okay, first we will discuss these important fats. I think then it will be more clear, because for this we should know the concept of cholesterol. So first we will discuss this important fat in our body, then we will again come back to the saturated and unsaturated fatty acid. Okay, so till now we are discussing about fatty acid. Now we will discuss about fats. Fats is derivative of fatty acid. So first important fat in our body is present in the form of triglyceride. So as I told you, fatty acid combines with one other molecule to form fats. So triglyceride is a type of fat in which fatty acid combine with glycerol to form glyceraldehyde. So in this triglyceraldehyde, three fatty acid attached to one molecule of glycerol. That's why we call this as triglycerides. I will explain this. Like if a fatty acid combines with glycerol, I am denoting this fatty acid with F and this glycerol with G. So if one fatty acid will combine with one glycerol, then we call this as glyceride. If two fatty acid will combine with this glycerol, means F2 plus glycerol, then it will be diglyceride. And what is triglyceride? Triglyceride is three fatty acid with one molecule of glycerol. And this is structure of glycerol. In this glycerol, three fatty acid. This is one fatty acid, this is other fatty acid, and this is other fatty acid. All these are connected with one glycerol molecule. So we call it as triglyceride. So this is also important. Most of the fatty acid in the body are also in and are
Sir, can
also
you move a little bit up to the structure?
okay. This is structure of
Where uh, where is the fatty acids here?
okay. Fatty acid are not present in this picture. This is structure of glycerol. Like one fatty acid will be connected to this point. One fatty acid will be connected to this point, and one fatty acid will be connected to this point. This
Okay.
is glycerol, and in this glycerol, three fatty acid will join to form triglyceride. Structure of fatty acid we already discussed. This is just structure of glycerol. Clear?
Yes, sir.
Okay. Okay, now this point is important. Most of the fatty acid in our body, or we can say most of the fat in our body or in nature, occurs in the form of triglyceride. So please mark this point as important. Triglyceride is most abundant type of fat. Okay, so triglyceride is a slight larger molecule. So in order to pass it through cell membrane, first triglyceride is broken down and then again it enters into cell and then again it's unite to form triglyceride. This is not that much important. Just this line is important, like fatty acid are present in the form of triglyceride and this is most abundant form. This line we will try to understand in this paragraph how triglyceride is digested. So triglyceride are broken down into free fatty acid and monoglyceride and glycerol. Okay, I will explain this. As I told you, a triglyceride, there will be three fatty acid and one glycerol molecule. So on hydrolyzation, it can be broken down like three fatty acid will become separate and this glycerol will also become separate. First breakdown can be like this. In this, a triglyceride is broken down into three fatty acid and one molecule of glycerol. There can be one more breakdown of triglyceride, like there will be two free fatty acid and one glycerol molecule will be connected to a single fatty acid. What we call this?
Sir, mono.
Yeah, monoglyceride. So that's what this line is trying to explain. Like whenever there is hydrolysis of fatty acid, whenever there will be digestion of fatty acid, it can be digested into free fatty acid, it can be digested into monoglyceride or glycerol. So all these are absorbed into intestinal cell, and again these are rebuilt into triglyceride. Like this line also want to convey the same message. These are trying to explain that in our gut, in our digestive system, triglyceride will be broken down into fatty acid and glycerol, and once they reach blood, in blood again they will form triglyceride. Is it clear? Okay, do I need to explain one more time?
Yes, sir.
Okay, this is triglyceride molecule, and this is our cell membrane or intestinal wall, and this is blood vessel wall. So what happen in digestion? Food from our intestine goes to blood vessel. So triglyceride molecule is very big molecule to go through this wall. It is very big for that. So what happened? This triglyceride is broken down into fatty acid and glycerol, and all these fatty acid and glycerol then transported to the blood, and again they unite to form triglyceride again. Is it clear?
Yes, sir.
Okay, so I want to say that in the blood, triglyceride is also present, although cannot uh, it cannot pass this intestinal wall and blood vessel wall, but it pass in the form of fatty acid and glycerol, then again unite to form triglyceride. Okay, so this is triglyceride. Triglyceride, the function of triglyceride. Triglyceride is most abundant fat in our body. Most of the fat is present in the form of triglyceride. And in nature, also most of the fat is present in the form of triglyceride. Next is phospholipid. So phospholipid, just like triglyceride, there is the fatty acid are united with glycerol. In phospholipid, the fatty acid are united with phosphorus. Fatty acid, glycerol, and phosphoric acid and nitrogenous bases. So these all are constituent of phospholipid. You just need to know that in triglyceride there will fatty acid, there is glycerol, and in phospholipid along with fatty acid and glycerol there will be phosphoric acid and nitrogenous bases. No need to remember this nitrogenous bases. Actually, this nitrogenous bases is not its specific property. This is present in almost most of the fat. So in phospholipid, along with glycerol, there will be fatty acid, there will be phosphoric acid, and there will be nitrogenous bases. You just need to remember this phosphoric acid, or you can directly just remember with this resemblance like phosphoric acid, phospholipid. Because of present of this phosphorus, these fats, these lipids are known as phospholipids. And one more thing, please don't confuse between fat and lipid. Both are same thing. So in this fat, in this lipid, phosphorus is present along with fatty acid and glycerol. That's why we are calling this as phospholipid. So phospholipid is not necessary to provide a phospholipid in diet. In our body can produce this phospholipid. We are getting fatty acid, we are getting glycerol, in the form of triglyceride in our diet, and we are getting phosphorus from various food like banana and all. So our body can produce these phospholipid. And the most important thing in phospholipid, it is function of phospholipid. Please remember this function of phospholipid. Main function of phospholipid, it takes part in fat digestion. Like in our large intestine, phospholipid helps in digestion of fat. Next, phospholipid are important as component of active tissue. Active tissue means those tissue which are always in phase of generation and regeneration, like brain, nervous tissue, and liver. These are active tissue of our body. So phospholipid are important component of active tissue and cell membrane. Cell membrane is made up of this phospholipid. Around 60 to 70% of our cell membrane is consist of phospholipid. Again, they are powerful emulsifying agent and are essential for digestion and absorption of fat. Please star mark this term emulsifying. I will explain this when we will discuss digestion of fat. What is emulsification? Why emulsification is needed? So of phospholipid. First function is digestion and absorption of fat. Second function, it is a component of active tissue and cell membrane. Next, phospholipid help to carry lipid particle across the cell membrane in the bloodstream. Same thing, like fat help in absorption. So what is absorption? Absorption is carried out lipid particle. Okay, just 1 minute. Okay, so this absorption is explained here, like phospholipid help to carry lipid particle across the cell membrane in the bloodstream. Those two membrane were there. First is wall of intestine and other is wall of blood vessel. So phospholipid help to carry the lipid particle, fat particle from our intestine to our blood. Is it clear?
Sir, can you summarize it once?
Okay, so phospholipid is a type of lipid, type of fat in which fatty acid, glycerol, phosphoric acid, and nitrogenous bases are present. Phospholipid is very much important for digestion of fat. It helps in digestion of fat. It is also an important component of active tissue and cell membrane, and it helps in digestion and absorption of fat. And why Why this phospholipid helps in digestion and absorption? Because this is powerful emulsifying agent. This powerful emulsifying agent, what is emulsification, we will discuss in digestion of fat. Is it clear?
Yes, sir.
Okay. Different terms are here, so please, after this class, please revise this topic, because fat is very much confusing as compared to protein and all, because there are different types of fatty acid, there are different types of fat. So that's why initially I told you that don't confuse between fatty acid and fat. Okay, next is cholesterol. So cholesterol, as we all heard of this cholesterol, and in a very bad sense, cholesterol is always taken, but it is not like that. Cholesterol is also a type of fat, just like phospholipid and triglyceride. Cholesterol is also a type of fat, and cholesterol is very, very important for our survival. Cholesterol is essential part of each cell, and every human cell makes cholesterol. Cholesterol is essential part of each cell. Like each cell needs this cholesterol. Each day, our liver makes about 800 mg of cholesterol. Each day, our liver is producing this cholesterol, which circulate through the bloodstream and is used wherever it is needed. So liver is producing maximum amount of cholesterol. Liver is producing this cholesterol and then circulating this cholesterol in blood. So whichever tissue or wherever this cholesterol is needed, that cell or tissue will absorb this cholesterol from blood and then will use this cholesterol. Cholesterol, why cholesterol is needed in our body? Cholesterol is precursor of vitamin D. What is this precursor? Precursor means raw material. This vitamin D, for the formation of vitamin D, for formation of some hormones, as I told you, some steroidal hormone are there. So for the synthesis, for the production of those steroid hormone, and even for the production of bile acid, cholesterol is needed. That's why it is written that it is precursor of vitamin D, it is precursor of hormone and bile acid. The hormones made from cholesterol include corticosteroids, estrogen, testosterone, and calcitriol, the active vitamin D hormone. All these things, like these hormone we have already discussed: corticosteroids, estrogen, testosterone. What is this calcitriol? This calcitriol is vitamin D hormone. Means you can understand, like an enzyme need to produce vitamin D. So that's why it is written that cholesterol is also a precursor of vitamin D. What is scientific name of vitamin D?
Not sure, sir.
Okay, okay, I'm also not sure. It is like calcitriol. This is scientific name of vitamin D, and this is made up by a cholesterol, cholecalcidiol. Okay, right now I'm also not sure about this. I will just
Calciferol, sir. Calciferol.
calciferol. Okay, okay, thank you. So calciferol is this vitamin D, and this calciferol is made of by a cholesterol, cholecalcitriol or diol. There is something I am missing that word, so I will let you know later. So this cholesterol is very much important for our body. Cholesterol is needed for production of this bile acid, and this bile acid in turn are needed for fat digestion. This is all written here. So next is lipoprotein. Okay, one more thing. In infant stage and in toddler stage, new tissues are formed, especially brain. So for formation of new tissues, cholesterol is also needed. So it is written in our Ayurveda and in our different like Ashtanga Hridayam and all. Fat is very much important for growing children. Nowadays, people are just preventing children to have fat or something. People are using some fat which are not that much lubricating, like olive oil and all. So in growing stage we need cholesterol, especially for development and of brain and neural tissue. We need cholesterol. Cholesterol is not always bad, but in next class we will discuss about good cholesterol or bad cholesterol. Why most of the people takes cholesterol as a bad term, although it is very much important for our body. Then why it is considered bad, we will discuss in our next class. Cholesterol is clear?
Yes, sir.
Okay. Just don't try to mix up all these things. Don't get messed up with all these things. Just remember function of each and every fat. Like again, I am repeating about cholesterol. Cholesterol is made up by liver. Some of the cholesterol we also intake by diet. And cholesterol is precursor of vitamin D, hormones, and bile acid. Cholesterol is very much important in infant stage and in toddler stage. Now next one is lipoprotein. So lipoprotein are synthesized in liver. Liver is also synthesizing this lipoprotein, and they are composed of 3/4 to 2/3 of lipid. Means they are very much abundant in our body, and the main important function of lipoprotein, these lipoprotein are serve as a fat transporter. Like I will explain this. Like fat is not soluble in water. If you try to dissolve fat in water, it will not be dissolved in water. It will just be on the space on the surface of water, and it will not be dissolved. So our blood is made up of around 70% of pure water, 95% there is plasma, and 70% we can understand there is water. So blood is just we can say a derivative of water. So if fat is not soluble in water, so how can fat, this all triglyceride and all, how can be these are soluble in blood? And if these will be not soluble in blood, how can blood transport all these? Because for transportation, these all things are need to be soluble in blood. If these are not soluble in blood, then what will happen? This is blood vessels. Blood will flow in these blood vessels, and these fat molecule will be on the surface of blood vessels. These fat molecule will not be get transported because these are not soluble in blood. Am I clear? Is it clear?
Yes, sir.
Okay. Is there any doubt on this?
No, sir.
No, sir.
Okay, so for transportation of fat, as fat are not soluble in blood, so for transportation of this fat, there is one more different type of fat. We call this as lipoprotein, means protein containing lipid. So lipoprotein are a type of protein that contain some lipid, and these act as a transporter. Like what these lipoprotein do, if there is one fat molecule and it need to be transported in our body, these protein will make a covering outside of this fat molecule, so that this fat molecule will get dissolved in water, and so that these fat molecule will be transported to our body and will be used wherever it is needed. So whether uh, triglyceride, whether there is phospholipid, whether there is cholesterol, all these fat molecule will be joined with this lipoprotein in order to transport it throughout the body. So this is main function of lipoprotein. Okay, is it clear now?
Yes, sir.
Yes, sir.
Okay, so now let's discuss the most important topic in this fat, saturated and unsaturated fatty acid, and this cholesterol and all. You are having class by 7?
No, sir, it starts at 8, the next class.
Okay. Okay, this is cholesterol. And if this cholesterol, as I told you, fat is made up of, what is the basic unit of fat?
Fatty
Fat,
acid.
fatty acid.
acids.
Yeah, fatty acid. So this cholesterol is made up of fatty acid. So if this cholesterol is made up of saturated fatty acid, if this cholesterol is will be made up of saturated fatty acid, then the lipoprotein to transport this cholesterol will be LDL, low density lipoprotein. Again, I am repeating what happens if this cholesterol is made up of saturated fatty acid. Then the lipoprotein used for transportation of this cholesterol will be low density lipoprotein. And if this cholesterol will be made up of will be mostly made up of unsaturated fatty acid, then our liver will use HDL, high density lipoprotein, to transport this cholesterol. Again, I am repeating, if a cholesterol molecule is made up of saturated fatty acid, then the low density lipoprotein is used to transport this cholesterol. And if a cholesterol molecule is made up of unsaturated fatty acid, what happened? This HDL, high density lipoprotein, are used to transport this. Now, what is the problem with this saturated fatty acid, cholesterol, and low density lipoprotein? As this low density lipoprotein have very low hold, I'm writing here low density lipoprotein. These have very low power or low hold. So what will happen? These low density lipoprotein, when transporting cholesterol from one place to other place, they drop some cholesterol. They drop some cholesterol in the blood, and this cholesterol starts accumulating on the surface or on the lining of our blood vessel. So what will be the consequence of this? The consequence of this will be slowly our artery will be narrowed. After time, there will be more deposition and there will be more narrow our artery will. Are you understanding this?
Yes, sir.
Now, benefit of this HDL. As this HDL is having very high hold, this HDL has very high hold. So this HDL do not drop that cholesterol in between, and because of that our artery remain very clean. One more function of this HDL is that suppose this is blood vessel, there is some cholesterol and a HDL molecule is going through this blood vessel, then this HDL molecule will also try to attract this cholesterol. So what will happen because of this HDL, there will be chances that the arteries may get cleared, may the cholesterol from the surface of this artery may get cleared. So in summary, we can say that if we are taking saturated fatty acid, then our body will produce LDL cholesterol. And in our body, who will produce this cholesterol?
Liver.
Liver, yes. So there is high chances that this LDL cholesterol will get accumulated in our arteries because of very high, very low hold, very low power of this LDL, low density lipoprotein. If we are taking unsaturated fatty acid, then this liver will produce HDL cholesterol. Then this liver will produce HDL cholesterol. It will not block our artery, or it will try to clear those arteries. So this is benefits of having unsaturated fatty acid. This is benefits of having plant-based oil, and that's why even non-veg meat is a complete source of protein. It is not recommended, and because of this presence of saturated fatty acid, slowly it starts to blocking our arteries. Now there is a disease. Okay, one more point left in this, you can write this. If this production of LDL cholesterol and production of HDL cholesterol is also depend on one more thing, on our lifestyle. On our lifestyle, if our lifestyle is active, means we are doing some physical training, we are doing yoga, gym and all, then there will be high chances of production of HDL, high density lipoprotein. And if we have sedentary lifestyle means we are not doing any physical work, we are physically inactive, we are just sitting all the day, then there is high chances that our body will produce LDL. So this is also one more factor. And again, one last factor is also there that is responsible for HDL and LDL, that is diet itself. From diet, in diet also LDL cholesterol directly present and HDL cholesterol is also present. Like if you check the label of something like any chips packet or any biscuit packet, if you check the label, there is written like this contain this much LDL cholesterol, this contain this much HDL cholesterol. So we also intake this HDL cholesterol or HDL cholesterol directly from our diet. 20% cholesterol comes from our diet, and 80% cholesterol is formed in our body, and that formation also decided whether we are having saturated fatty acid in diet, whether we are having unsaturated fatty acid in diet, or whether our life is physically active or we are having sedentary lifestyle. So now
So there
let's,
are saturated and unsaturated fatty acids in the previous slide. Those are created because of the food that we take, right? Naturally, how would they be?
yeah, this saturated and unsaturated fatty acid present in our diet. From diet,
Yeah, then how do we say that diet only contributes 20%?
yeah, diet contributes only 20%, like directly 20% of cholesterol comes from diet. But that 80% of cholesterol is also being formed from our diet, but this formation is taking place in liver.
Okay, sir.
Okay. Uh, any other doubt? Okay, this 80% which our liver is producing, this also depend up to some extent on diet, like whether we are taking saturated or unsaturated fatty acid, or whether we are physically active or physically inactive. So there is one more condition, I will discuss this, atherosclerosis. This is also known as CHD, oh sorry, CAD, coronary
Heart disease, right? CHT only, sir.
artery disease. Yeah, CHD is also there. CAD means coronary artery disease, and CHD means coronary heart disease. So first we need to know about what is this coronary artery. You know about this coronary artery?
That's present in the heart.
Yeah, coronary artery means the main function of blood is to provide oxygen to each and every organ, but our heart also need oxygen na? So to provide oxygen to heart, there is some pipeline present, there is some blood vessels present, and those blood vessels are known as coronary artery. So if this our normal artery, if this our artery of our hands, our legs, if this normal artery, and if this get blocked due to this LDL cholesterol, then it will not be good for us, but we can survive this, because what happened, we will have pain in our hand will get low oxygen because of this low blood supply. If this gets completely blocked, and then our hand may get there will be numbness, and there will be clotting in this blood vessel. This can happen. But what happen if a coronary artery who is transporting blood to the heart itself, who is providing oxygen to the heart itself, what will happen if this coronary artery will get blocked? What will happen?
Then there will be a um, cardiac arrest.
Yeah, there may be cardiac arrest. The main thing that will happen, the heart will not get enough amount of oxygen. If the heart is not getting enough amount of oxygen, then what will happen? The heart tissue will start dying, because they are not getting enough amount of oxygen, and then there is acute pain in heart. This acute pain is also known as cry of heart. and in scientific terms we call it as angina pectoris. Because heart muscles are not getting proper oxygen, that's why there is acute pain in those heart tissue. In heart, this is known as cry of heart, and in scientific term this is known as angina pectoris. And after some time there will be cardiac arrest or heart attack or MI, myocardial infarction. This is scientific terms for heart attack. So this is long-term consequence of this coronary artery disease, atherosclerosis. That's why it is known as a silent killer, because by the age of 2, not teenage, not 20, 30, 40, by the age of 2, this cholesterol start accumulating on the blood vessels, on the line of blood vessels. And at the age of 40, 50, 60, based on our dietary habits, this layer starts becoming thick. And when it will be that much thick, like it will directly block the artery, then directly the patient will get angina pectoris. That's why it is known as silent killer, because in first there is no symptom, the patient just have a little pain in his heart, that is also not uh, always present there. The patient don't have much symptom, but suddenly there is cardiac arrest, there is angina pectoris. That's why it is known as silent killer. And that's why most of the doctors, they don't recommend non-vegetarian diet, because non-vegetarian diet mostly contain this saturated fatty acid.
So
And
what is myocardial infarction?
myocardial infarction is scientific term for heart attack.
And pain, it's a angina pectoris is the name for the pain.
Pain, acute pain in heart, cry of heart. This angina pectoris is a primary sign of myocardial infarction, heart attack. Okay, so is it clear?
Yes, sir.
Okay, is anyone having any doubt in this? Okay, I will, yes.
No, sir. No doubt.
Okay. 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 Is anyone having doubt in this? Please, I will share the slide. Please go through that slide till we have completed. Please go through that slide. And if you have any doubt, uh, in next class, first 5 minutes, if you are having any doubt, then we will discuss those doubts. Then we will move forward. So please go through those slides, and you can leave now. In next class, we will continue from here. Thank you.
Thank you.
Thank you, sir.
Thank you.